Hello everyone. Welcome back to another yuHacks workshop. Welcome to day 4 of our workshop week. I'm sure you guys are sick of seeing my face by this time, but if you guys are not, thank you again so much for joining us. For this workshop, we have a really exciting workshop topic that we'd love to bring you. So today's topic is Conv-Neural Neural Network with Keras, and today we have two panelists coming in to talk about the workshop. So our two workshop hosts are Kevin from CSHub President and Minh Vu from CSHub as well. Hey guys, how are you doing?
Hi, thank you for
Hello,
the
hello.
introduction.
Hello everyone. So could I get a short introduction from both of you guys?
My name is Min, and this is Kevin. We are all both from CSHub. And
Mhm,
today we are presenting about how to make a convolutional neural network in Keras.
mhm.
And after this workshop, we hope that you can actually make one, like a machine learning model on your own. Yeah,
Awesome. Sounds exciting. All right, the stage is yours. Go for it, guys, and good luck.
thank you so much. Okay, hi everyone. Good afternoon. So today we are talking about convolutional neural network in Keras. Just a quick look at our agenda. So first, we are going to talk about just a little bit of theory because machine learning is kind of theory heavy, and the code is actually very short. And the second part will be like the main part of the workshop, which is coding and actually making a machine learning model. And our task today is making handwriting digit recognizer. Sorry. So first, because maybe many of you not have heard about machine learning. So machine learning is the task of making computers more intelligent without explicitly teaching how to behave. So there are so many tasks today that we cannot really explicitly code. Um, for example, like making a recommender system or something um, like a voice recognizer. So yeah, because we can't really explicitly program them. Uh, we have to use machine learning to solve such problem because machine learning is a very powerful tool that can learn like very complex patterns in data. So application of machine learning, there's spam email filter that you can see in many mail system like Gmail. There's classification, which is the task that we are doing today, which is handwriting recognizer. Yeah, this is classification where um, we train our data to classify into classes, and then there is speech recognition, and then recommendation system, which is you can see everywhere, like Facebook, YouTube, or even Amazon. There are so many places that use recommender system, and there are a lot more because machine learning is a very powerful tool, and it can take very powerful and very complex pattern, and it can be used on many fields. Next up, we'll talk about neural network. So neural network is a special type of machine learning because yeah. So um, in machine learning, there are two kind of type of machine learning. There is classical machine learning, which is very, I would say, non-scalable, or it's very hard to scale. But neural network is something else because you can scale neural network very easily by just adding layers or adding the complexity inside hidden layers. So how it works is that you have an input layers, and at every um, hidden layers, you you can do mm, you can do very complex mathematics in each node, which is like you can imagine it is a neuron in your brain. So information in, and every node there is connected. So what I mean is it's very complex, and it can really learn really complex patterns, which made it so powerful. And so convolutional neural network is actually just just a neural network, but it has convolutional layers, which we will learn now. So convolutional layers is just I don't really want to go over the math today, so convolutional layers is just a special layer that can capture spatial 2D patterns, like patterns in images. Yeah. So how it works is that it contains a filters, like a set of filters, and the filters can evaluate one images through the convolution operation. But I will not go over it today because it kind of complicated. Yeah. So basically, it can learn very complex 2D patterns. And our task today is making handwriting-digit recognizer, and we will use um, the convolutional layers that I just mentioned that can learn patterns, because in this task we have to uh, learn some patterns from the digit so that we can actually classify them. So convolutional layers is a perfect candidate to use. And yeah, so our data will be our data will be 28 by 28 images with label. So uh, just to summarize what we have to do today, we're going to go through 3 steps. So first is building the model, second is training, and third is validating the model. Okay, it's time to go. Um, Wait, hold up. Um, okay, so here's my notebook. So I will post a link to the notebook on the comment section. Can you see the link? So the link will get you to this notebook, and you can actually save it and make modification. Yeah. All right. Yeah. So if you press it, there will be an option to save your notebook here. Like normally, you will be here to save it to your drive, and then you can make some modification on it. Okay, I assume that everyone got to this part. Um, okay, so before moving on, I have to clarify that, because what I say that we had 2 steps, right? We have building and training and validating steps, but actually, um, there one more, just a few steps that we have to take before actually making our model, which is data preprocessing, because we kind of want to make our data to fit, you know, like to be compatible to our model, so that we have to perform some sort of modification before we move on. So first is import. This is like we're importing very basic model, basic library, NumPy, pandas, and such. Those two are for this is for visualization. So first we must load our data. So here we have 2 separate set of data. First is training data and then test data. So test data we will use to validate our model. and train data will be used for training our model. Here, okay, actually, I should restart runtime. Okay, so this is the dimensions of our data. We kind of want to know this because we would like to know like what steps to do or what or how our data looks like. So first we will inspect the dimensions of our data. So here we can see that there are like almost around 20,000 images here in our train data, and the dimension is 785. So when I look at it, so because I know that 28 multiplied by 28 is should be something even. So and it is kind of an odd number, so I kind of assume that the label is there. Yeah, it's very weird. Yeah. So yeah, those two are the type of the data is a data frame. It's just kind of redundant, but yeah. So first we need to, because as I said, there is some label like a dimension for a label in the training data, so that we have to split it into two. So here we are splitting um, the training like images and the training label into two separate sets. And I would do the same with test data. And here is a plot that shows the distribution of the labels. Just some statistic, but you don't really have to know this. And then there is the conversion to from data frame to NumPy array, because it's very easier, much easier to operate on NumPy arrays. So this is just a conversion from type to type. So this is like from data frame to NumPy array, yeah. And so we kind of want to uh, see like have some knowledge on how our data looks like. So this step is just printing out labels and how the image actually looks like. You can see there's very ugly, badly written handwritten digit, and their associated labels. But you guys don't really have to know this. Oh, this six look. The six looks very ugly. It's kind of weird. Three is very weird. Yeah, there will be very weird like numbers in our data, but I hope that our model can like classify them correctly. Okay, next up is data preparation. As mentioned before, we kind of want to make our data compatible to our model. So you I don't really have to know this. I just want to walk it through. First is reshaping, because um, as seen before, okay, actually here, as seen before or as in here, um, the data is actually an array of numbers. It's actually not uh, it's not an 2D array. So sorry. So it's an array of 784. So what we actually want is image representation of 28 by 28. So it's like square. But like we are having, what we're having now is just a straight array. So we kind of want to form it into a square image of 28 by 28. Yeah, so this line does it. You see the difference here. This is an array of numbers, and this is another kind of arrangement so that we have this 28 by 28 image. Next topic is label encoding. This you don't really have to know this. It's just changing the form of the label so that we can do classification with it. And this kind of required, but like yeah, you don't really have to understand. Mm, and then we also want to do splitting data. So because okay, so in machine learning there's several um, sets of data that we have to like work with. First is training data that we can train our model with, and there is also validation data that we have that we can use to like verify the performance of the trained model. So so that's why we need to split them into two. And there will be another one called test data, which is here. This one is the final step that we so you can play around with training and validation data. This test data must be kept very secret, and you only use it for the final verification of the model performance. So yeah, so that is kind of like the best practice. So here we have split our data two um, two different sets. So this set is the training data, and this set is validation data. And now here comes the juicy part. I would call it juicy part because we are making like coding convolutional neural network from you know coding coding from the beginning. So here is our model. So imagine a model is like a, a sequence of layers. So first we have our input layers, and then we have like convolutional layers, core layers, um, flattened layers, and then a dense layer. So this layer is for classification. These layers, convolutional layers, as I said before, it is for pattern recognitions. Correlators is for like simplifying our model, like yeah, simplifying our model a little bit. This pattern is required for this dense layer to classify. So first we are building our models. So yeah, first we have to like import our first we have to import like TensorFlow, and then we have to import this sequential from Keras models. So because as I said, the convolutional neural network is just a sequence of layers. So yeah, that is the name, sequential. So yeah, we can specify like what kind of layers that we want to put in this sequential parameter, which accepts an array. So first we are making uh, our convolutional layer first. So the syntax is convolutional 2D, yeah. And actually, there's a lot more like parameters that we have to pass in. It's more like a modification, like a modded 2D layers. So first we can specify our like the number of filters that this layer can have. So filters, yeah, we will use like 32 filters, and also we can specify the layer size, the filter size, which can do with kernel size. Yes, we specify the kernel size, which is 5 by 5. So imagine each filter is on 5 by 5 series, like, yeah, matrix one way. And then, yeah, we have to specify patterns, which is this thing you don't really have to know. I find that is nicer to work with, but you can play around. There are actually different kind of patterns, but I find this nicer to work with this one. Um, and then you have to specify activation. So activation is like activation is like how your model or how this layer validate, not validate, evaluate the value from the input, from its input. It's kind of, really just use ReLU for this one because it's the most common type of activation function. Yeah, and also because this is the first layer of the sequential of the sequence, and we haven't specified input layer yet. It's the way Keras work is that you have to specify the input layer, that the dimensions of the input in the first layer of the sequence. So we have to specify the shape of the input here, which is 28 by 28, and we only have one channel. So there can be many channels, like a normal image would have like 3 channel for colors, but we only have one today. Yeah, it's like RGB. And and we would like to add another layer like 4 2D layers. Mm. So what this does is that we simplify our model. So imagine a 28 by 28 image, and the result of this is squish, a squish image. So we really have to know the theory behind this, but yeah, for the sake of our tutorial, let's do 3 by 3 full size. And then we add a flatten. So what this does is that imagine that we have a 28 by 28 image. The flatten will actually flat our image into like one array of numbers. So it's like 750 something uh, numbers array. And then finally we have this dense layer, which we can use to actually do the classification on artificial is softmax, because softmax is usually used for classification, so it's kind of different from ReLU. So normally I would just wanna use ReLU on the middle layers, and the last layer, like imagine classification, for classification tasks, I will use softmax because it is used for classification. So yeah, this is our model. And it not okay. That was wrong. Okay, it's done. Um, Also, we can do to actually view this, have a summary of the model. We can do model dot summary. So this will print out the statistic, like how many parameters, the output shape of each layers, and the total parameters. So the more parameters, the more complex your model is, and sometimes you kind of feel like the model fitting or the model training is taking too long. You can actually look at this statistic to know like which layer has the most layers, so that you can actually modify it to be similar uh, if you want. But 26,000 is not really that much. But yeah, next up is compiling the model. So this is just like a, I would say, a blueprint, and we kind of have to compile. So we can do model.compile. So our parameters here, there will be two parameters that we have to use today. First is the loss. Loss is like the metric that we define the performance of the model. So the more loss would 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 equate to the more inaccuracy of the model. So we kind of want to minimize this loss. So our loss is categorical cross entropy. We have to like know this, right? Yeah. And the metric is accuracy. And then there are some settings for our training. So first is epoch and batch size. So this is just some basic setting for our training. You can definitely try to change the number. It actually can affect your performance of your model. I think I've changes and improved my model somehow. But yeah, the best practice is you should try to play around these. Um, these are called like hyperparameters, where you can play around and influence your learning, like how the model learn. Yeah, and it can actually improve your model as well. Yeah, so here we want to perform the actual training. So this is the building step that I have mentioned. So here we build our model and we compiled it. Now is the second step, which is training the model. So I've specified the record like variable here. So what this does is that it um, can save the progress that maybe in the future we want to visualize the model when it is learning. So the information or the history of how our model is doing will be contained here. So here we do model or fit. So fit here you can understand as training. So there are some parameters that we have to work to like input. First is the train, which is our image, like training images, and the label that correspond to the to the training image. So this is the image, and this is training model, training layer, training label. Sorry, and and then we can have validation data, which we already split the training data into training and invalidation, and then validation. Yeah, and then we can batch size, and then epoch. This option will print out like the progress, and so these two, as I have mentioned before, these two are like the setting for our training. You can actually play around with it and maybe somehow improve your model. Yeah, so let's run this. Actually, run this. Yeah, so the epoch will be like it's the number of how many times our training data is used. So it's like a round, a round of training. So we have 10 rounds of training at the moment, and it's training right now. So first is the loss. As mentioned before, we want to minimize this loss. So loss is like the inaccuracy of our model in terms of training, no, in terms of classifying. So we kind of want to minimize this loss so that it will make like a better, like a better classification. Yeah, our accuracy in the first epoch is like training accuracy is 0.71, but after the second epoch it's actually improved quite a lot. And then there is validation loss, validation accuracy. So our model will not learn from our validation data. The validation data is here just for validating actual validating and evaluate the performance. Yeah, so this finished training. Training accuracy is very high. Actually, this is high too. The validation accuracy is actually high too. Okay, so if you have gone like have passed this step, you're actually making one like machine learning model. So the result of this will be we will have a model that can actually classify from unseen data. It's still running somehow. Okay, it stops. It finished. Okay, so yeah, it is like everything. Like so, this after this step, you already have a model that can actually detect the data. No, not detect, but classify the data, and all everything is contained in this variable here. Um, and the step three would be like validation because we kind of want to measure our model's performance. So first is you would like to look at the training and validation curve to see if you can actually improve somehow or if there is some any problem or issue in our learning. But yeah, we'll see this part. Yeah, And yeah, step 3, evaluation. So remember that we have this test data that we save for the last validation, and so we will use this now. So our model will be, so after training, our model will be contained in this variable. So every time you want to like use our model to actually make classification on unseen data, you can use model.predict. So our prediction, so after running this, our prediction will contain like the label that corresponds to the image that we have in the input data here. And for visualization, you know, before, so for visualization, we'll print uh, the input like image, and we'll print the prediction of our model. So as you can see here, is it does a very good job on classification. Like these are the unseen data. Oh my god, this is very weird. But yeah, we can see that it actually actually awesome. Yeah, it can actually classify our data really well. And let's see our accuracy score. Holy shit. Okay, so our accuracy score is actually very high. I've never gone in this state, so our accuracy score is actually 99.2% on unseen data, which is really good. Like really, really good. I'm amazed. And to see like further statistic on how our model is performing, we'll use something called um, a confusion measure, which is like this. So our confusion metric would plot a statistic of like the label that your model got correct and the labels that that is misclassified. So as you can see here, so our model actually wrongly classified the number 4 with number none and the number 7 with number none, which is kind of weird, but yeah. So this is a statistic that you can see. So like the you can actually see this, and maybe you can actually improve the model. Yeah, I think, yeah, that is everything for this workshop right now. Yeah, if you guys have any question, post it now, because I know that there are many things that I have not explained, because I I'm scared that there's no time. Actually, there are a lot of time. So please post your question. Okay. Oh yeah, sorry, right? I didn't catch. Okay, so what is this platform? So this is like a not Jupyter Notebook. It's Google Colab. It's actually Google Colab, and is this better than IDE for doing AI code? So the thing about like Colab, Jupyter Notebooks, or maybe Kaggle notebooks is that you can. So there are blocks of code. Firstly, there are blocks of codes that you can actually print, like output your result like at the end of each blocks. So it's very convenient. So you don't have to run everything, and you don't really have to print like like explicitly explicitly print out the output, and it just shows up in like in this very neatly form. Also, you can do markdown, which you can add like photos, you can add like plots, you can add a lot of things here, which I would say very convenient because in a sense that building a model, training and validating our model is kind of sequential. So you kind of want to, maybe you want to add some text, some explanation, graph, whatever, and it will create a very good like visualization tool. So I would say that yeah, it's actually I would much prefer to make my machine learning model on this platform. Actually, I've made no, actually not. Okay, yeah, actually prefer to work with this platform. Also, this is not my computer as well, so the resources is free. So Google Cloud provides some RAM and some CPU like for free, and you kind of want to do this because there are models that are very complicated, and you don't want to heat up your computer or run the computer all night, or maybe you don't really have a powerful computers. So yeah, so this is very free resource between AI and ML. AI is actually so AI is like a superset of machine learning. So machine learning is okay. So AI is how can I say this? AI can also detect patterns. It can do like intelligent things. But the thing that differs from machine learning and that differs from machine learning to AI is that machine learning is a special kind of AI that learns from data. So in AI, um, you can actually program it somewhat, but in machine learning, you don't really have to explicitly program anything, and you just have to feed the data into your model so that it can learn. No, it can learn from the data, and the way our machine learning model behave actually depends a lot on the data we feed it in. So from this model that I have presented, you can actually detect or classify different kind of flowers. You know, using this the same thing, you can actually make it do a very different task. Something like um, classifying cats and dogs, or classifying different kind of flowers using the same machine learning model. So what is different is the data we feed it in. So that is machine learning. In AI, it's the superset. Yeah, you can do so. In AI, you can somewhat program it some way, and there are a lot more options. Yeah, I hope it answers the question. Also, yeah, another another question could be like, what is the difference between machine learning and deep learning? So this is a kind of deep learning. So deep learning is like we use a lot of architecture that is very complex. So this is almost near deep learning because the architecture is just a sequence of layers. So deep learning is like a sequence of layers that it has a lot of layers, and it does so by combining different um, neural network altogether. They can be convolutional neural network, can be neural network, and it combines together like a Lego block, and it very deep, very a lot of parameters. So I've seen a deep learning model that has like 900 million parameters, which is very big. So this like a very tiny small scale of deep learning. You can actually do deep learning on this exact same thing. Machine learning is like no classical machine learning. It's actually much simpler. It doesn't really use neural network, and it uses some very basic or very I wouldn't say basic, but it uses different algorithm to do classification. So you may heard of naive Bayes. You may heard of very hmm, what else? Logistic regression. Yeah, so that is classical. So yeah, you can use like R or MATLAB. I think I have used MATLAB for um, k-nearest neighbor classifier before. Java, I have never seen one. I have never seen one. C sharp, maybe. I think I have heard about people using C sharp before. Actually, so no, to train a model, you can use not just CPU, but you can actually use GPU to code or to train because using GPU is actually much more efficient. Yeah, thank you. So using GPU is actually much more efficient. So, but like to actually use or to actually code GPU friendly code, you kind of want to use something C sharp. Mhm. Yeah, yeah. I'm scared that I went too quickly. we have like 10 minutes left. Actually, I don't know like how much RAM or how much CPU Google gives to you. Uh, I think in Kaggle. Yeah, actually this mine. So I don't know how much Kaggle gives to you, but Kaggle is very awesome. They give you like free GPU, free CPU, free RAM, and they are very generous with it. I would say. No, let's see. Yeah, you can use GPU, you can use GPU, and yeah, free space. It gives you 16 gig of RAM. And what about CPU? I don't remember. Yeah, basically very small. It's actually somewhat better than my laptop right now. Yeah, I like cable. I don't know how much it is, but apparently it doesn't have GPU here, where cable actually gives you GPU. Yeah. Okay, so NumPy and pandas. So I have like compile a note on this thing. Wait, So pandas. So what pandas does? So basically, these two libraries they they provide a data structure. So data frame is one data structure. NumPy array is a data structure. But the thing is that you can do different operation with them. Um, Data frame is very powerful if you do like operation that is vectorized to an entire thing. So it's something like database or database entry or whatever. So it's very hard to do math on pandas. Um, the data frame you can do it, but like it's very slow. But data frame you can do like statistic on it very easily. So something that you do in a very large scale to do pandas, whereas NumPy array is kind of more math heavy, and you can do more types of math and math manipulation or matrix manipulation here, and it's more efficient. So to sum up, like pandas you use for like statistic to visualize your data, and NumPy you use it for um, manipulation of numbers. You can do a lot of math operation here. Yeah, so that is the difference. Here, I can use NumPy mostly. It's very easy to split the data and actually train a model. Yeah, but basically they provide like data structure that you can manipulate your data. It is very useful to learn them for if you want to do machine learning in Python. It's like the basic that you have to do, that you have to learn. But you don't really have to learn that much. You just need to like get to a problem, try to solve it, and Google along the way. Also, two two more libraries that you should learn is the visualization because this plot is actually use matplot and seed1 to plot them because you kind of want to visualize your data so that you know what to do. Yeah, so you need to use these two visualization library for this task. Also to visualize like how well your model is doing. Yeah, very useful. Yeah, Keras is very nice. That you can actually do like make a model in a very short amount of code, and you can train it very quickly. The the long part is just you know data preprocessing and then tuning. But yeah, oh sure. Okay. How do I do it? Okay, hold up. you should like connect with Kevin as well. I think he's okay. You should connect with Kevin as well. Okay. So let's wrap this up. Thank you so much for watching. Everyone from this live stream or future viewer. Thank you so much. I hope you
All
learned a
right,
lot
that was a
today.
really nice workshop. Thank you so much to Minh for hosting and coming in to show us how that works. Thank you so much, Minh.
Thank you. Thank you for hosting.
Yeah, I hope everyone got a lot of information out of that workshop. Thank you everyone for joining. Please join us for our next workshop, which is at 6 o'clock, which is in about 4 minutes. It'll be about how to get your internship at big tech companies. Thank you, everyone. We'll see you in the next workshop. Bye,
Thank
everyone.
you. Bye.